Welcome to qnawire.
We have another simple ideal Rankine cycle. Not a simple one. We have two stages of reheat. So we go through reheat, and then finally come back to the condenser. So we have we're told the network out of this plant is, or this system is 75 megawatts. Low pressure side is at 30 kilopascals, high pressure side is at 10 megapascals. Temperatures up here are 550 degrees C. And then this pressure is 4 megapascals, and this pressure is 2 megapascals. So, saturated liquid at 1, specific enthalpy, specific volume, get the power in, and get the specific enthalpy at 2. Looking at let's see here, looking at 3.3, we get the enthalpy and the entropy from there. And so going down to 0.4, we know it's assuming we're an isentropic turbine, so we have this relationship here. Now we have a new pressure, and so we get an enthalpy at 4. And then at 5, we have 4 megapascals, and we're back up to 550 degrees C, so we can get the enthalpy and the entropy again. And then at 6, we know the entropy is the same as at 5, and now the pressure is 2 megapascals, so we can get the enthalpy again. And then finally at 7, we know that the pressure is 2 megapascals and the temperature is back up to 550 degrees C, so we can get entropy and enthalpy again. Now we can look at 3 at 0.8 here, and we're down here at 30 kilopascals, and we know that the entropy at 8 is the same as at 7. So we find that we have a quality factor of about 97%, and then we can also get the enthalpy at 8. And so with that, we have the enthalpy at all of our inlets and out exits. So we can then look at the heat transfer in. So the heat transfer in is H3 minus H2 plus H5 minus H4 plus H7 minus H6. So all of these parts right here are where we have heating. Adding that all up, we get 3,814 kilojoules per kilogram. The specific heat out is just enthalpy at 8 minus the enthalpy at 1. And so that winds up being, about 2,268 kilojoules per kilogram. The net work is then the difference between these, and we get that. And then we can find the efficiency. Well, we can either take this divided by this or 1 minus this divided by this, either way. And we get that the efficiency is about 40.5%. Again, this would be for an ideal mechanical devices, turbine, and pump. And since we were given the net power output and we know the net specific work, we can find the mass flow rate of the feed water through here, and that winds up being 48.5 kilograms per second.